Greetings and welcome, friends. We're taking a look at page 40. We were solving literal equations or rewriting equations and formulas, whichever way you'd want to talk about it. And the idea was that even though I had multiple variables in my equation, I was going to solve for one of them and pretend as though the other ones were not variables. Just treat them as though they're numbers. So here we go. I want to solve for y, so I'm locking on. That's the variable I want to solve for. The operations that are occurring to y, it's being multiplied by 2 and then subtracted by, just pretend a number, okay? All right, just pretend that's a number. So I've got multiplication and subtraction. If I want to undo what is happening to y, I've got to deal with subtraction before multiplication, because remember, we SAD map. So I'm going to add 18x to both sides. And even though I'm writing it here, it's not actually a like term with this. I'm just kind of trying to squeeze it in right there is where I want that there. So let's see. So I'm going to have 2y, because negative 18x and positive 18x are 0. I have to write it. Equals, I'll have 18x minus 26. And so now to undo what's happening to y, it's being multiplied by 2. The inverse would be, of course, divide by 2, which you could write it as all one big fraction. But in this case especially, I noticed that these terms are both even, therefore divisible by 2. So you can write div 2 for both of those. And I'll have y equals 18 divided by 2 is 9, still with the x. All right. And 26 divided by 2 is 13, still with that minus sign. So here is that equation solved for y, and that was the idea, was solve it for one of its variables, and you just treat all other variables as though they were numbers, not variables. Okay, let me actually tell you what, bonus question, 2y minus 18x equals negative 26. Same question if I wanted to solve for x. I just want to show you the idea here. X is being multiplied by negative 18 and added by 2y. So I would move the y to the other side in this case. Do you have a question? Yeah. All right. Well, hopefully we can learn from our mistakes. Yeah. Okay. Well, that's all right. So it's just a short tweak then. So yeah, to solve for the variable, that means the variable is completely alone on one side of the equation, and the variable then also doesn't exist on the other side of the equation. So let's see. So to get x by itself, divide by negative 18 both sides. Wow, this one's a little grosser for sure. So let's see. I'll have x equals negative divided by negative is positive. 2 and 18 are both divisible by 2. 2 goes into 2 once and into 18 9 times. I'll write that as 1/9 y. This y is next to it. It's not under the denominator. You could have written this as y over 9 as well. That's fine. Negative divided by negative is positive, so I'm going to write this as a plus sign. Both of those look like they're divisible. Here I'll just write some 2 went into 2 once and into that 9 times. And this one looks like they're both even. 2 goes into that 13 times and into 18 9 times. So let's see, I'll have plus 13 ninths would be the solution there. So so that's the idea. Solve for the variable, pretend all other variables are just numbers, and depending on which variable I solve for, I'm going to have a different outcome. The benefit of this skill, one of them, is that if I have a formula, I could solve for one of the variables, and now my formula will always tell me what that thing is equal to. If I wanted a formula for the height of a rectangle, I could just have h equals a divided by b, and then whenever I know the area and the base of a rectangle, I just plug it in and I know the height. Question, comment? Yeah. Oh, yeah, I will. Don't worry. I'll wait at the end of the video. They'll survive for a moment. Let's see. This one is, oh man, this one's so tricky. Solve for the literal equation for x. Here we go. So notice, I've got two X's here, which actually also, in terms of Mr. Waddy's romantic life, I have exactly two X's. I've only ever dated 3 people. So there you go. 2 X's here in this problem as well. I have 0 regrets. So here we go. One of the ways that I'm going to have to deal with this is, we talked about it, factoring out, which was like undistributing. That's going to be an idea throughout the rest of this course that we'll practice a lot, so don't worry. So I'm going to pull an X out of those. So it's like I'm collecting taxes from each of those terms. I'm not pulling an X out of the 6 because it didn't have an X for me to take. So 6 is going to be hanging out on the outside of those parentheses. All right. So let's see. I pull an X out of the term 4X. So now my question is, X times what would have equaled 4X? The answer is 4, right? If I was to redistribute, X times 4 would have been 4X. And then X times what would have been RX? X times R, positive R, would have been RX. So now I've got a single X that I can solve for. That's much better to deal with. And so X is being multiplied by, just pretend this is some big number, right? And it's being added by 6. So now let's start getting X by itself. Subtract 6 from both sides. I'm going to write it here, even though these aren't like terms. I'm going to try to squeeze it right into that space. So I'll have Y minus 6 equals X times 4 plus R. And now let's see, what do you guys think? X is being multiplied by 4 plus R in parentheses. How could I get X by itself? What's the inverse operation of multiplication? Division, yeah. So even though this looks big and massive and weird, I'm going to divide both sides by this number, which is 4 plus R. I don't actually even need the parentheses because the fraction bar itself is a grouping symbol. And let's see, now I'll show you what happens. This goes ching and ching. Look at how awesome that cancel is. I love it. And we'll flip it around, so I'll have X equals, and it's just this fraction, Y minus 6 over 4 plus R. So I can't do any simplification there. Someday we'll talk about simplifying some things like that. That might even show up more in Algebra 2 in the future. Yes, idea, question, comment. Yeah, I'll come back to that one afterwards. Okay. Yeah. Let's see. Well, here. Okay, here we go. I'll pull 15 up on the screen. Yeah. Here, I'll do the start on it anyway. So let's see. So we're solving for X here still. The same idea. I would steal an X out of both of those, which is what they did. And they'd have, yeah, that's weird, isn't it? So let's see, X times what would have been 2X? That's 2. And X times what would have been 6XZ? Well, everything except the X, so plus 6Z. All right? Yeah. So, and then you can kind of check yourself. Think about, would this distribute back in? X times 2 and X times 6Z does, in fact, equal those things. And then my last step, yeah, we just got a bonus question here. Someone was passionate about 15. That's okay. Over 15, right? Divide both sides, and then that's what I saw on that piece of paper as well. They canceled those out, and we do, in fact, get X by itself equals A divided by 2 plus 6X. C, good call. Thank you. Good save. Bam. All right, so there's 15. So this undistribution concept, it's tricky. All right, it's tricky, but don't you worry. We'll do a lot of practice on that. Let's see. I wanted to do 29. This is such a classic problem. This is the area of a trapezoid. So let's see if I have a trap. See, I'll try to do a non-isosceles trapezoid here. This is what information we're talking about. So the area is the area of the inside here. You've got base 1, this dimension right here. We'd have base 2, this dimension right here. And then we would have the height, which is perpendicular to the two bases. So it could be there. Usually it's measured from the edge of one, would be the height. So that's kind of the information that goes into the area of a trapezoid formula. And they're asking us to solve this equation for B2. All right, so base 1, base 2 is what those stand for. The little subscript does not mean multiply. It's just like the second name for that variable, what that is. So if I want to solve for B2, oh man, this one is tricky. Let me actually rewrite this problem, give myself a little space. Yeah, this is a classic problem. Students all across America are going to be doing this exact problem in September every year for perhaps forever. Yeah, interesting. So I want to solve for B2. B2 is locked inside these parentheses. I actually have to deal with this first. Now I could choose to distribute. Yeah, my preference would actually be to divide both sides first. But let's say we distributed. But I think that's something that we would have been more comfortable with at this stage in the game. But so yeah, so we'll try that. So area is going to equal 1/2 h times base 1 plus 1/2 h base 2. Okay? Still trying to get base 2 by itself. Base 2 is being multiplied, all right, by this thing, and it's being added by this thing, right? So I want to deal with this part first, the thing that it's not being multiplied by. So I'm going to subtract 1/2 h b1 from both sides, right? I know this is weird. It's like, where did the numbers go? This problem's practically all letters, right? And that might be scary, but don't you worry. Equals, all right? So those were not like terms, notice. So that's why I just wrote a minus that thing. Equals, now I'd be left with, these canceled out, which is what I would have expected, equals 1/2 h b2. Now, to deal with the 1/2, I might do this in 2 steps. I could have also, I guess, simplified this as h over 2, multiplied both sides by the reciprocal. But let's just multiply both sides by 2 right now. I think I like that idea. I'm just going to deal with the 1/2 first, and then we'll deal with h later. I can do this piecemeal. So notice that multiplying by 2, these would cancel out. On the LHS, the left-hand side, I'd have to distribute. So I'm going to get 2a minus 2 times 1/2. What do you think, Austin? 2 times 1/2. 1. Yeah, 2.50 cents, right? That's $1, right? Yeah, 2 times 1/2. The 2's cancel out. It's just 1. So this is going to be HB1 equals HB2. All right, I've almost got B2 by itself. It's being multiplied by H, so I'm going to divide each side, and I'm not even going to do that as each term by H. I'm going to flip it, base 2 equal to 2a over H, right? Base 2 is in fact by itself because these would have swiped. And also check out this fraction. Can I reduce anything here? This. So this is just going to be minus base 1. Fail on the box. There we go. All right, so now what I have is the base of a trapezoid formula when I know the area, the height, and the other base. Okay, so the benefit of that is that if I knew 3 pieces of information, I could now find the 4th in a formula, just like, bam, here it is. I just plug it in and PEMDAS it, rather than plugging that information in piecemeal here and having to solve every time. Okay, so that's what that allows me to do. But these problems definitely a little bit tricky. It's weird working like where did my numbers go, right? Like, who put alphabet soup in my math class? What's going on? This is crazy. Don't you worry. Body's here. I'll hold your hand. We're gonna walk through this. This will be great. I'll hold your hand mathematically, metaphorically speaking. So anyways, have a great day, internet friends. Bye-bye.